Let's delve into the Studio Web interface. On the landing page, you'll find various solutions you can create. With Studio Web, you can build, test, and deploy agentic processes, agents, RPA workflows, or apps. Let's select Agent. The main designer canvas is where you design your agent. There are 3 types of agents you can build at UiPath. Autonomous agents, which are designed to execute based on a single comprehensive user prompt. Conversational agents, which are built to handle back-and-forth interactions, understand context, ask clarifying questions, and respond to user input in real time. And coded agents, which are built through direct code development within a developer's preferred integrated development environment. In this course, our focus will be on autonomous and conversational agents. Coming to the designer canvas. You can utilize the assisted autopilot approach for designing your agent. Simply describe the agent you wish to create and click on Generate Agent. You'll learn more about this approach in another lesson. Let's now create an autonomous agent from scratch by clicking on Start Fresh. The definition panel is where you design and define your agent's core elements. It comprises general, tools, contexts, and escalations as its sections. You can define the prompts for your agent in the general section. Using tools, you can connect to runtime tools like integration service connectors or publish processes. The context section enables you to link organization-specific knowledge sources using context grounding indexes. This gives your agent relevant data access. Escalations, on the other hand, help you set up human-in-the-loop fallbacks. On the left side panel, you'll find the Project Explorer. From this panel, you can access the agent definition, evaluation sets, and evaluators. The Evaluation Sets panel is where we create evaluations and store results. These evaluations objectively measure the output of your agent and assess its consistency with your objectives. Moving on, the Evaluators panel is where you create and manage the evaluators used in evaluations. From here, you can add a new RPA workflow, app, agentic process, or agent to your automation solution, or import some existing ones. Let's try adding an RPA workflow to this solution. Notice that the workflow file appears directly in the Project Explorer panel, allowing you to switch between your agent and the workflow file easily. Next, you can use the Data Manager panel to define input and output arguments used in your agent or any variables and entities to be used in the automation solution. For instance, if you wish to add customer email as an input argument, simply click here and provide the name and description. If there's a need to change the data type of an argument, you can do so by selecting the required data type from here. Content is the default output argument. You can modify its name, description, or type accordingly. You can also add more input or output arguments as per your requirement. The Errors panel highlights design time issues, broken configurations, or failed test runs, while the deployment configurations can be viewed here. Finally, the bottom left part of the interface displays the components that can be part of your automation solution. On the right side, you'll find the Properties tab, where you can adjust both agent-level and component-level settings. For instance, here you can select the agent model, adjust the creativity of the response, and set the maximum number of tokens generated per response. The Agent Score feature allows you to gauge your agent's readiness based on evaluation results and test coverage. The current score is average because we haven't configured any of the agent's components yet. By using the Run Output panel, you can review the results from the most recent test runs. Leverage Autopilot to get AI-powered suggestions to refine the prompts, tools, and agent setup. You can also share your solution with your colleagues and collaborate further. Once you're ready with your agent, use the Debug option to test the output and further refine the agent design. Finally, when you are done with testing, evaluating, and refining your agent, you can publish it to Orchestrator by providing a suitable location and proper versioning. With this exploration, let's now go ahead and configure our pre-built activity search agent. For this demonstration, we'll use an activity search agent to showcase the functionalities of an agent. Let's import this into Studio Web and open it. Remember the components of an agent: instructions, tools, context, and escalations. Each of these components plays a crucial role in determining how the agent interprets requests, processes information, and executes actions. Instructions guide how your agent thinks, behaves, and processes information through three key elements: the system prompt, arguments, and user prompt. The system prompt outlines the agent's core identity, capabilities, and limitations. Think of it as your agent's instruction manual and ethical guidelines combined. Observe the best practices for the system prompt. The agent's purpose and role have been defined along with the tasks it should perform, the constraints, the expected output, and a fallback plan. Depending upon the requirement, you can also add instructions around when, why, and how any tool should be used, and when to involve a human in the loop. You'll also notice that the agent requires some input. In this case, it's a city and a specified group size. These arguments are like function parameters in programming and are defined in the Data Manager panel. Both are mandatory inputs. If you want to change their data type, you can do that from here. The output is an array of activities, each represented by an object containing a title, summary, and maximum group size. As a best practice, it's advisable to provide a description for each agent argument. These descriptions serve as an additional prompt to the underlying AI model and actively influence how the agent interprets and handles each argument. Clear and specific descriptions help the agent understand the purpose and expected format of each argument. User prompt helps you define a structured way to pass arguments to your agent during runtime and frame the conversation. To incorporate dynamic input into your user prompt at runtime, enclose the input arguments in double braces, like city and number of people. During runtime, these placeholders will be replaced with the actual values provided as input. You can also provide additional specific instructions as part of the user prompt. Next comes tools. These are the practical actions that are autonomously triggered by agents during their execution to interact with systems and accomplish tasks. You can add automations, other agents, activities, and API workflows as tools. In this case, we have used two tools, Web Summary and Web Search. These activities are part of the UiPath GenAI activity bundle. So to use them, you need to establish a UiPath GenAI connection. You can use an existing connection or define a new one. This needs to be done for both the tools. Context is the next important aspect. It allows your agent to reference your organization's specific knowledge bases, documents, and data when responding to queries. To add a context, simply click here. You have the option to select from a list of indexes or create a new one based on your specific requirements. You'll see its usage and configuration in subsequent videos when you build an agent from scratch. Now you may want to give your agent a way to validate business case details with a human before running a tool, or to request manual assistance if they encounter issues. In other scenarios, there may be business exceptions in a process where you want an agent to have a human make an approval or some other type of decision. That is where escalations come into play. Using this, you can design and configure human in the loop events in agent execution. With everything set, it's time to test the agent. Click on Debug. With every agent run, you spend AI units. Wouldn't it be nice if the expensive real system calls were replaced with controlled mock ones? Simulations help you with this by providing precise control over the testing environment. You can choose which components to simulate, the inputs or agent tools. Thus, your agent can rehearse and practice with mock data and test out different scenarios before connecting to real systems. Let's simulate the tools used in our activity search agent. Under Project Arguments, provide the value for your input arguments. Next, expand the Tools section. Set the Simulate toggle to On for both the tools. Once done, click on Save and Debug. You can see a list of activities in the output along with a brief description for each. You can also see the simulated result of your agent's web search tool and the web summary tool along with the different web portals which have been used to generate the response. Based on these outcomes, you can refine the prompt if necessary. Finally, let's examine how to evaluate our agent. We'll start by creating several evaluation sets. Navigate to the default evaluation and rename it to Custom Evaluation Set. Note that the evaluator is set to the default evaluator. Next, click on Add to Set and provide the values for the input arguments. For instance, use London for city and 15 for the number of people. Even though we'll be looking for a structural match, it's recommended to provide some values for the title, summary, and max group size fields present under expected output. Here, we have provided values like activity title, activity summary, and a value of 2 for the max group size field. Save these settings. In a similar manner, add Berlin with the number of people as 5. Use the same values for the title, summary, and max group size field. And finally, add Madrid with 15 people. Now that we've established the evaluation set, the next step is to customize your evaluator. The default evaluator type is set to LLM as a judge. This type provides a flexible evaluation of complex outputs and can assess quality and correctness beyond exact matching. However, if the output requirements are strictly defined as an exact match or, say, JSON similarity is needed, use the deterministic evaluator type. Trajectory evaluator, on the other hand, uses AI to judge the agent based on run history and expected behavior. Next, use the prompt provided in the evaluator prompt txt file. By default, this will compare the expected output against the actual output. Let's cross-check that. Go back to your evaluation set and open one of the evaluations. Here you can see the previously defined expected output. However, our goal is not to seek a deterministic approach where we know the result in advance and simply compare and match those results. Instead, we want the results to be evaluated. In this case, we'll specify that the actual inputs, such as the title, a potential title of a group activity, and a summary of the activity within the title need to be checked. This implies that the summary should correspond with the title. Moreover, we'll also specify a maximum group size, which should either contain the number of recommended people or indicate no limit. These additional rules guide our evaluator. Furthermore, we also state that the expected output, the example we provide in our evaluation sets, doesn't need to exactly match the actual output. Once the preparation is complete, proceed to run your evaluation set. You can observe that the evaluations are being processed. Upon completion of the evaluation, a score is generated. In this case, we have achieved a high score. It's evident that for each scenario, we have received a high score. We can view the results for each scenario individually. If an unexpected output was provided, it could be compared, especially if we expected certain activities to be already present. Regardless, the evaluation remains effective as we have a list of correct activities in which we can participate. Now let's check the health score for the agent. This is an objective score used to identify areas where an agent needs optimization or additional training. You can see that individual scores are available for each agent component, including the prompt, the tools, the input schema, and the evaluation. Each component receives a score from 0 to 100. The final score report provides a weighted average of all component scores. Now, let's look at the prompt score. This is evaluated on several factors such as clarity, completeness, consistency, and chain of thought. Perhaps adding some examples that the agent can utilize to achieve the correct result will help in achieving better ratings for demos. We can see that we have used the correct tools. The input schema looks great too. We have 2 arguments, and we use them both. There is room for improvement in the evaluation score, although it fares well on the schema matching part. However, the number of sets we've utilized is not sufficient. The agent score considers 30+ evaluations as a good benchmark. That brings us to the end of this demonstration. See you next time.